solve equations with degree higher than 1. Previously, we learned to solve equations that looks like this, say 3x plus 7 equals 9. It could be complicated with parentheses and x is on the left side of the equation, on the right side of the equation. But all those equations, and if you look, I could add maybe 5x to the right, but the variable x, as you can see, the exponent is 1. X means x to the first. So the highest power of x is equal to 1. So in this case, we call it the highest exponent, we call it the degree. So what's degree? The highest exponent of the variable. But what if we have like x squared or x third or so on? So for example, we may have an equation like x squared minus 5x equals 0. In this equation, we have x to the first and x to the second. So the degree is going to be equal to 2 in this case. And because that's the highest exponent we have of the variables. And how do we cannot solve this like we did before because we cannot combine like terms. So previously these are like terms, we can combine them, move this to the left or move this to the right to combine them. But in this equation, x squared and the 5x, we learned this before, they are not like terms, they cannot be combined. So there's no way we can combine all the variables to get a single variable of x and then try to get x by itself. So this doesn't work anymore. We have to solve this kind of question by a new way. So the idea is based on a very simple property of multiplication. So if suppose I have two numbers, unknown numbers, we don't know what they are, but I tell you that after we multiply these two numbers, we end up with 0. So what can you say about these two numbers? Let's call this number 1, this number 2. And notice that when we multiply two positive numbers, a positive times positive, we will get a positive. We're not going to get a 0. When we multiply a positive and if one of them is positive, the other is negative, we're going to get negative. It's not going to be 0. When we multiply two negatives, we will also get positive. You're not going to get 0. So if number 1, number 2, if none of them is 0, there's no way we're going to get a 0. So you can see some examples. Say 1 times, like say 2 times 3, you're going to get 6. You're not going to get 0. Even if you change them to negatives, say negative 2 times negative 3, you get a positive 6, not 0. Or if one of them is positive, the other is negative, you're going to get negative 6. It's not 0 either. So in order to get a 0, one of these two numbers, either number 1 or number 2, has to be 0, because 0 times any number is going to be 0. So possibly you could have the first number 1 is 0, or you could have the second number 2 is 0. But one of them has to be 0. So in order to multiply to get a 0. And this also works with more numbers. Like if you have 3 numbers, say you have another number, let's call this number 1, number 2, number 3. And similarly, one of these numbers, either number 1 is 0, or number 2 is 0, or number 3 is 0. Notice that we don't need all of them to be 0, but we need at least one of them is equal to 0. So this is the property I'm talking about here. So let me erase some of these here. So the property can be summarized here. If the product of 2 or more, you could have 3 or 4 or 5, as many as we want, of numbers is 0, and then one of them must be 0. So when we multiply, notice product means multiply, and it has to be multiplication. It cannot be addition or subtraction. So if the product of 2 or more numbers is 0, which means the right side has to be 0, then one of them must be 0. All right, and so the solution is going to be based on this. Whenever we solve equation with the degree higher than 1, this is one approach we will take. This approach may not always work, but this is the first approach we will try. Okay, so based on this property, we can summarize the steps we have. So notice that it says the product is 0. And look at the format we have. So the product, something times something is 0. So you must have the equation, whatever is given, you must change it to this format. Something times something is 0. So this tells us, first, the left-hand side, one side, we can say one side. This could be on the right side. Usually we keep the complicated one on the left-hand side. So step 1, the other side is 0. So you have to make one side 0. If the other side is not a 0. So make one side 0, and which can be easily done. If it's not a 0, you can move it, everything to the left. So the right side will be 0. Now step 2, the first thing you want to make sure one side is 0. In this case, I have the right side is equal to 0. So we'll first make the right side 0. And the left side, you have to make sure it's a product. So how do you get a product if it's not a product? We do factor. Factor the other side, because we know factoring can change anything to a product. Factor the other side, and that's step 2. And step 3 is based on the property. So once you get this format we have, something times something equals 0, then you can say, use the conclusion, the one of them must be 0, which means either this is 0 here or this is 0. So either the first number is 0, the second number is 0, which we call them factors here. We know if it's product, we call each of them factors. So in step 3, we will set each factor, or you can say each parenthesis, you set each factor equal to 0. So we have these 3 steps here. And if you remember this property, these steps can be remembered. So if the product of 2 is 0, then one of them must be 0. So product, do factoring. One side, make it 0. And one of them must be 0, so you set either the first is 0 or the second is 0. So let's go back to the example we talked about here. So in this problem, notice that we cannot combine them. So we're going to try to take this approach here. Okay, so I need to make one side 0. Well, one side is already 0. So that's, we can skip step 1. We don't need to do that. Now, the other side has to be something times something. But we don't have something times something. We have something minus something. But since we learned factoring, and this is the greatest common factor type, so we can factor out. Notice that x squared and x, they share x in common. We factor out x. And x times what is equal to that? So we just divide both of them by x. So divide the first one by x, divide the second one by x. X squared divided by x, we get x. 5x, we cancel these two x's, we get x minus 5. So this is the greatest common factor type we did before. Previously, the questions given, we just have x squared minus 5x. We ask you to factor, and you factor out x, so you get x times x minus 5. And now here, so that's the left-hand side, we do that factoring. And the right-hand side, we just keep it. Now, so we have the format we need now. Something times something equals 0. So we do have something times something equals 0. And by the conclusion, we know either this first is 0 or the second is 0. So notice this is like our first number. This whole thing is the second number. So we have something times something equals 0. So we have x equals 0 or x minus 5 equals 0. We set each one equal to 0. If x equals 0, we're done. X is already by itself. There's nothing to do. But if x minus 5 is 0, we got to add 5 to both sides. And then we get x equals 5. So we got 2 answers. X is either equal to 0 or x is equal to 5. We can test our answer, check whether they're correct. By plugging back into the equation. So if x is 0, we got 0 squared, which is 0, minus 5 times 0, which is 0, and 0 minus 0 is equal to 0. If x, so which means this is correct. If x is 5, so we're going to get 5 squared, which gives us 25, minus 5 times 5 is also 25. 25 minus 5 is equal to 0, so that tells us this is also correct. So now let's look at another example. What if the other side is not a 0? So we have n squared minus negative 3m. So in this case, notice that we don't have the format yet. So the right side has to be 0, but it's not. So let's add 3n to both sides. So we have to do first step, step 1, make one side 0. How do we make one side 0? We just add or subtract whatever need to be done. If it's minus, I do addition plus. Because notice negative 3n plus positive 3n, that gives us a 0. Sometimes we cancel them out. We don't write down anything because we already have something there. But if you don't have anything, you do need to write down the 0 there. On the left-hand side, n squared plus 3n, they're not like terms. They cannot be combined. We just have to leave them. Just write down n squared plus 3n. So now we got first step down, make one side 0. Now the right side is 0. The second step, you need to factor the other side because we want to have something times something. So again, this is, so far we only learned greatest common factor. So we're going to find out x squared, n squared and n, they have an n in common. So we factor out n and divide both of them by n. So we're going to get n plus 3 equals 0. So now we have the format we need. Something times something equals 0. Step 2 is finished. So we just need to do the last step, step 3. Set each of them equal to 0. So this is like the first number. This is the second number, n plus 3. So it's either the first is 0 or the second is 0. If the first is 0, we're done, nothing to do. The second is 0, we have to subtract 3 from both sides to get n equals negative 3. And similarly, you can plug both numbers in there to check, to verify they are both correct answers. So the idea, in later sections, after we learn the other factoring types, and the factoring part, which is right here. So this is the factoring part. We did GCF, but later we may have other factoring, like for example, difference to squares or trinomial or other types. So this step may be different, but the idea will be the same. These 3 steps will be the same.